and she'll be talking about the mining industry in Iran, the potential and the challenges. Fatemeh got a Bachelor of Mining degree from the University of Tehran, and she got a master's degree, okay, from the same university as well. Okay, the master's degree's thesis was on remediation of AMD, acid mine drainage, using a sulfate reducing bacteria. And then after that, she had joined the industry and then worked in a consulting firm for a year, mainly focusing on the conceptual design of a copper concentration plant and also some feasibility studies. And then after that, she joined a contracting company for another 4 years, mainly focusing on iron ore, and she has coordinated a number of projects as well. So in 2013, February 2013, she has joined JKMRC as a PhD candidate and in the area of combination and also of localization. Please.
Good morning, ladies and gentlemen. Today I want to talk about the industry of minerals in Iran, and I will mainly talk about the problems and challenges we are now facing in Iran. And at the end, I will identify some of the potential this country has in terms of its mineral industry. To give you some overview about the content of my presentation, firstly, I give you some general information about the country, its geography, its population. I will show you a map of the distribution of mineralogy, and I will limit my presentation to some specific types of rocks and minerals, such as gemstone, quarry rocks, and in metallic minerals, I will talk about copper, and mainly my main focus will be in iron industry, where actually I was working. Iran, the old name is Persia, and it is located in Asia. And to be more specific, this country is located in Middle East. This is where Iran is located. Iran has several neighbors. On the east side, we are neighbor to Afghanistan, Pakistan. On the west side is Iraq, Turkey, and Kuwait. On the north side, we have Turkmenistan, Azerbaijan, and Armenia. And in north, we have Caspian Sea, which is the largest inland body of water, and most of our natural gases are sitting here. So we have huge reserves of natural gases here. On the south side is Persian Gulf and Oman Sea, and along this coastline is where we have most of our petroleum. About more than 20% of the world's petroleum actually passing from this area, Hormuz Strait. So this area has high importance in terms of its strategic location for international trade. We actually have 1% of the world's population, but we have about 7% of the world's natural reserves. As I told you, we have coastline on the Caspian Sea, and then on Oman Sea and Persian Gulf, which bring some benefits for us. Iran is highly populated. The population is about 78.5 million people, and the population density is quite uneven in Iran. About more than 10% of the population are living in Tehran, the capital city. This area, compared to the rest of the country, is quite small. The area of Tehran, just to give you some understanding, the area of Brisbane is more than twice as Tehran, but the population of Tehran is 4 times than Brisbane. The population growth was quite high, about 4% back in 35 years ago. It was when the government was pushing people to have more children after the Islamic Revolution. But it's now declined to 1.3% in 2013, although the government is still pushing people to have children. The young party, 60% of the total population is below 30 years old. So we are quite young. The archaeological findings shows that Iran was one of the leading countries in the mining industry in ancient time. We have 37 billion tons of proven reserves of minerals and 57 billion tons of potential reserves, and we have a variety of minerals, 68. But when it comes to the share of mining in GDP, it's quite small. As you can see, it's here in this graph, it shows the share of mining compared to the other sections of the society is less than 1%, about 0.8%. So it shows that Iran, in terms of its mining, is quite underdeveloped. And the reason for that may be because we have oil, we have gas, and the country's focus was to develop oil and gas industry instead of going to mining and developing. In terms of mineralogical map, this actually shows the mineralogical map of Iran for the common minerals. I haven't shown all of the minerals because it's going to be too crowded there. Most of our iron ore is sitting in the central part of Iran. Here in the province we call it Yazd, and toward the south and toward the northeast of the country. And most of our ports are sitting along the coastline and also in northeast east of Iran. We also have some coal here, but here is where we have fully mechanized coal mining. Our zinc and lead, they are in the central part of Iran. The mining method is underground mining, and here in Zanjan we have again lead and zinc, but it's surface mining. Our copper is situated along the copper belt of Iran, and here from the west east to the northwest of the country, from here to here. And this is where we have the majority of our copper in the province. We call it Kerman, and the mine is called Fatemeh. And we also have here in Songun. The photo in the first slide I've shown you, this that was the copper mine in this area. It's very cold, it's snowy, and it's very beautiful. So this is most of the minerals. We also have boric, we also have sternium, and phosphate here, chrome, most majority of chrome is here. There are other types of minerals. I'm not going to show all of them because it's going to be too crowded. In terms of mineralogical ranking, our turquoise is the #1 in the world. Our gypsum the second one, and we have other types of minerals. Our boric is 6 ones, iron ore 9th one. We have molybdenum as the byproduct of the copper, sitting in the 10th one, and then our copper is 12th one in the world, and we also have other types of minerals. But the mining GDP of Iran is quite, it's not comparable actually compared to other countries, as you can see here. But it's still substantial, about $8 billion in 2013. As I told you, our turquoise is the #1 in the world, but our gemstones are not limited to turquoise. We also have garnet in a variety of colors, chrysocolla, jasper, amethyst, and some other types of gemstones. We have extensive reserves of jewelry stones in Iran, but our export is limited. And the reason for that is because most of the jewelry mines, they are owned by private sector, and the government do not support them. Because most of them, they don't have the processing equipment for gemstone, and the government also is not supporting them to buy equipment for the processing. So we have the lack of governmental support in this context. And this is one of the turquoise mining in Iran, in this place. We call it Khorasan, and it shows the underground mining of it. Our quarry rocks are also famous in terms of the variety of its color and its quality. Specifically, we export granite and onyx and travertine. Onyx and travertine, these two types of rocks, they are all building materials, but these two types of rock are based on calcium-based rocks, and Iranians tend to use a lot of stones in their building materials for the exterior and interior design. So, again, despite having extensive resources of these quarry rocks, our exports are limited. Again, the same story, the processing method, cutting and polishing equipment, especially for these quarry rocks, these rocks require very accurate processing methods, and then most of them are owned by the private sector and the government is not supporting them. And specifically in the recent years, because of the problem of sanction, everything got worse and we have less export compared to the other years. Our copper actually is, as I said, the copper is situated along the copper belt here from southeast of the country to the northwest of the country. Saeidi is a place that has majority of copper, and Sungun after that. We totally have 2 billion tons of copper reserves. Saeidi has 1 million tons, and the rest for Sungun and Meidu. And this copper belt of Iran is actually the continuation of the andesite belt of Al-Himalaya. We have about 220,000 tons of copper produced in Iran and 280,000 tons of copper anode. The method of processing for copper is very conventional, similar to what we have in the rest of the world. We process both oxide ore and sulfide ore. If the ore is sulfide and it has high grade, it goes to concentrator. The main process is flotation, but we also have molybdenum as the byproduct of the copper, the molybdenum concentrate. We actually don't process molybdenum after this stage, but the copper goes to a smelter, to pacificator, to anode vessel, and at the end to electro-refining system, and we have at the end copper with 99.99% purities. And after this stage, the copper goes to produce copper billets and 80 millimeter wires. If the ore is oxide, the process is heat bleaching, and after heat bleaching, it goes to solvent extraction, and the method is using some organic solvent to leach the copper, and after that, it goes to electrowinning process. But recently, in the recent years, it was high tendency for the copper mines to process the low grade sulfide ore because of the price of the copper. And so what happened, actually, the company in Saeidi approached a company in South Africa, Wintec, and they actually bought some pilot plant equipment, the bioreactors from them, to do the bio-leaching of the sulfide ore. The process is sulfide is converted to the sulfate using some types of bacteria, they call it Tubacillus fructidans, and then after that it goes to electrowinning, and the process is similar to what we have for the oxide ore. But this was only in the pilot plant scale because of the huge investment they needed, and especially recently because of the sanction, they actually didn't continue to the full scale. Our iron ore is the ninth in the world. We have 4 year about 40 million ton per year of iron ore is produced, is extracted from the mine. Out of this number, we have 25 million tons of concentrate production and about 25 million tons of pellet production as well. The criteria for the concentrate before it goes to pelletizing plant is it has to have at least 68% of iron and less than 0.08% of sulfur and less than 0.04% of phosphor. Out of this number, the pellets, 25 million ton per year, we have 12 million ton per year of steel production. This is according to 2013 data. But the government is trying to achieve, the government vision is trying to achieve 55 million ton per year of steel production in 2025. This number actually, to me, is unrealistic, but this is what the government is trying to achieve. This actually shows one of the iron ore plants. It's actually 5 parallel lines of 2 million ton per year production, and it's situated in the central part of Iran. The iron ore industry is, we have magnetite and hematite like many other parts of the world, and our magnetites more are associated with the sulfur impurities, phosphorus impurities, and silicate. Especially in the central part of Iran, it's more sulfur impurities, and we also have silicate and phosphorus impurities. So the processing method is using magnetic separator, LIMS or MIMS, they call it low intensity magnetic separator or medium intensity magnetic separator, and it's usually followed by flotation to remove the impurities. The hematite processing hematite is more with electromagnetic separation, and recently we actually approached a Chinese company to buy some electromagnetic separator. The equipment, we call it Islam. It's a type of ferrous wheel, and this is several years ago when the iron ore price was going up. Everyone in Iran was trying to to produce iron and to get most of that. Especially the hematite processing is really difficult, but everyone was trying to get iron out of the mine. As I said, the government vision for 2025 is to achieve 55 million ton per year of steel production, and as I said, the number is unrealistic, but this is what they are trying to achieve. The previous practice was, they actually, because of this number, this is quite large, this production, they actually tried to give the engineering and design of the iron ore concentrator plants to the local companies instead of the foreign companies, firstly because of the cost and secondly because of the time. So the previous practice in Iran was most of the, actually all of the concentrator plants were designed by the foreign companies. Here you can see the list of the companies that were involved in the design of iron ore concentrator in Iran. For example, Chadormali concentrate, the photo that I've shown you in the other slide, that concentrator was designed by Kobe Steel and Chord and Sechamun. It was done by, I think it was an Irish company, Voestalpine. And Danieli, they have done the Sangon concentrate, and Autotape was also involved. But the current situation is that since 2007, they gave the engineering to the local companies. This is the list of the companies, the list of the concentrators that actually are designed by the local engineer. Not fully, but partially. So going from that previous practice, engineering by the foreign companies, to the current practice by the local engineers, it actually requires expanding our infrastructure and also improving our skills and knowledge for the iron ore concentrated plant. In terms of infrastructure, we have quite good access to the electricity network in Iran, and our telecommunication systems are highly developed. Our roads are developed to some levels, and we have some problem in mainly in the central part of Iran. But the bottleneck for the iron ore industry or other industries in Iran is the water. We are lacking water in Iran. So that's the problem at the moment, and I will discuss about this problem later in this presentation. For the knowledge and skill development, since the companies started to design themselves, they actually had huge employment from the oil and gas industry. And they also had employment from the people that were in the operation of the previous plants, experienced people. We actually had some consultation with foreign companies, and maybe the manufacturer and the vendors, and we actually developed and established our research and development team. As I said, water is a serious problem in Iran, mainly because most of the concentrator in Iran, most of the reserves are sitting in the central part of Iran, and this is where actually the area is quite arid and dry. And since the concentrators started to operate in these areas, the underground water level was going down every year. According to the latest information, every year about 1 meter of the underground water level is going down. So it's a serious problem. And also they have in these areas, especially in Kerman, they have some farming. Especially this area is very famous for its statue farming. So it's the conflict between the miners and between the farmers. And they had really serious problem providing water to water their crops. But to tackle this problem, the government actually decided to, they said probably we can bring water from Persian Gulf to Iran, to the central part of Iran. So they actually defined a project to supply about 500 million cubic meter of water from Persian Gulf to mainly 3 areas in Iran: Golgohar, Chadormanu, and Sarcheshme. As you can see, the elevation of these areas are quite high. So bringing water from here and from the quite long distance to this area, to this elevation is a really problem. And also that's for piping and different pumping station they need to put. And the other thing is that when the water come here, or maybe at the beginning, they have to do the desalination of water because it's quite salty. At least to some level that make it suitable for the concentration plants or for the farming. And this project is going to be done in 3 stages. Now the first stage has begun, but as the data shows that the progress is very slow due to some mismanagement. As I said, since we started to have the iron ore concentration plant, the design itself ourselves, we actually had huge employment from the oil and gas industry, and mainly the mechanical engineer, electrical engineer, instrumentation engineer. But the problem still was there. The problem was the process itself. The process in oil and gas industry is quite different from what we have in mineral processing. And I was working there, and I could see that the problem we had mainly was ore characterization. The only way we characterized our ore was by bond index test. Or we had some problems with the calculation of the capacity of the equipment and their dimension, and also with the scale up. And even with the equipment type, we actually didn't have any experience whether for example, for primary crushing, whether to choose Saeidi or HPGR. It was a long discussion between the client and the contractor for this issue. And about the flotation cells as well, we actually didn't know which kind of flotation cells can suit our requirement. And about fine grounding as well, dewatering also was a serious problem. And to actually have the plan, we had to pay attention to the equipment layout and pumps and pipes erosion, and then their maintenance. They were just running the plants, operating the plants. They never did the optimization of the plant. Let me give you one example of this type of problem. The company I was working with was the first company that they started to do the design themselves, and they were also the first company that brought HPGR to Iran, introduced HPGR. And first time they actually installed HPGR for the pelletizing plant to increase the blend of the concentrate. And then they said probably we can install HPGR and introduce Iran to the iron ore industry as a primary grinding equipment. Because they didn't have any knowledge about that HPGR, its operation and its working principle, they actually approached the manufacturer of HPGR. It was Polisius, ThyssenKrupp around that time. And they asked them to propose a flow sheet. This is the type of flow sheet that actually proposed by Polisius to the company. The crushing products comes to HPGR, and after HPGR it goes over the double-deck screen. The oversized material, they go back to HPGR, the undersized material goes to sump, and then it is pumped to the hydrocyclone, and the hydrocyclone underflow goes to a mill. Since they started to operate the plant, they had serious problems with the piping, pipes erosion and corrosion of the pumps. And the reason for that was mainly because the HPGR and the screen was located far from the area where hydrocyclone and the boiling was. So to pump the material, and the material was quite coarse, below 6 millimeters from here to here, they had high erosion for the pumps and pipes. And this is the photo. Actually, I've taken that. This is the pipe. They had the polyethylene pipes, but they actually got the tail legs because polyethylene was not suitable. They replaced it with tail legs. But still with tail legs, you can see they had problems. So the erosion and corrosion was too much there, and the maintenance was too much. So as I said, the problem was with the layout and with the layout of the plant, and with the high pressure of the pump, and the particles were very coarse, and they were also angular shape. This is the this picture shows the particle shapes and the angularity, as you can see. So they had some possible solution to actually convert the wet screen to the dry screen, so they could get rid of the pumps and pipes under the screen. And another option was to reduce the screening aperture. But the problem with this second option was the capacity of the plant would go down because of the screening aperture. And the other option was to change the layout of the plant and to add more pump station. Because around that time it was the high pressure from the client side to the contractor, they had to go for to do something. The client in Iran, they what happens there is they actually try to install the plant, and when they install the plant, they can go to the government and say, we have the plant, give the money to us. So that's the situation in Iran. So there was a high pressure from the client side to the contractor, and they actually went for the first option and got rid of these pumps and sumps here, and they replaced it with bed conveyor. They actually spent quite a lot of money here to do this, to destruct this the foundation without damaging the screening foundation, and to replace it with the belt conveyor. Not only they actually spent money on this issue, they also had oversized equipment, because most of the time the HPGR, actually all the time, it was running below this power. The installed power was 2.2 megawatt, and out of this installed power, they were always using less than 400 kilowatts, so it was quite low efficient. And also the bulbing was quite inefficient. Out of 5.5 megawatt, they were using only 3 megawatt. The reason for that, they didn't actually have any model to model themselves, and I think the company also oversized the equipment for them. And the other thing was the sampling maybe was wrong, because, as I said, they first go to install the plant, to do the design for the plant, and then they go to do the design for the mine. So they didn't have the right samples for the design. This is one problem. Just let me give you another problem. Is for flotation cells. This flotation, as I said, the iron ore in Iran, the magnetite is associated with some impurities. In the central part of Iran, we have impurities of sulfur, and the company wanted to have a flotation cell to bring sulfur from 0.8% to 0.08%. So they actually, again, because they didn't have this experience, they approached the manufacturer of the flotation cells, Fatemeh, and they asked them to propose a type of flotation cell. This is the type of flotation cell, a smart cell elevated rotor. This was the type of flotation cell that was proposed by the by Fatemeh. This type of flotation cells, they are elevated type of rotor, because the rotor, instead of being down in the tank, it's located close to the top of the tank. The other difference of this flotation cell with the previous one, with the conventional one, is that this doesn't have the forced air. Actually, it's self-aspirated. So what it does, it actually, when the rotor rotates, it actually brings the air from the outside environment to the flotation cell and create turbulence in the system. So, but the problem was, they actually had this system in copper industry with success, but when we actually started to operate the plant, we actually realized that as soon as the iron comes to this flotation cell, the magnetite started to settle down. So this actually blocked this concentrate, because this type of flotation was reverse flotation, and the concentrate goes to the bottom of the tank and they tail to the top. So they had blockage, they couldn't use this system, and sadly the problem was they had repeated this system in 7 other plants. Each plant was 2 million tons per year of copper, of iron ore concentrate. So they have lost a lot of money, and they now not using this system anymore. And the other problem with this was, since we started to operate it, we asked for the Fatemeh supervisors, and because of the sanction around that time, they were refused to send a supervisor. So that was quite sad, and that was the situation. Now, I already talked to you about the problem of the technical problems, and about the water problem, the issues we had for the design, but I like to talk about a problem which is very serious in Iran, and it's sanction, because it actually impacted the industry of mining a lot in Iran. So the sanction actually targeted the oil and gas industry of Iran, and actually some of the assets of Central Bank of Iran was frozen within the European Union, and then it was actually a ban on selling precious precious metals to Iran. But the sanction was not only this, it had huge impact on the society. Our currency dropped by 4 times just within a year, from $1 equal to the 10,000 riyal to $1 equal to 40,000 riyal. So that was quite sad. Everything, the prices went up, and because of the economical crisis, we had a huge unemployment rate, and then we had problems with the money transfer because the banks were on the sanction, and then the market of the pharmaceutical products was quite low, and then we couldn't import some of the products from the outside of the country, and it was quite sad, especially for the patient, for the cancer patient. And also our air pollution went up, was worsened. That was because we actually were buying refined gas from the other countries, but since the sanction started, the government started to produce their own refined gas, and the quality was not comparable to the previous one, and the pollution was so obvious in Tehran, so it got worse. And in terms of the academic activity, the Iranian student didn't have enough access to the academic resources, the journals, articles, and that was this problem still is going on. About the effect of sanction in mining, it was huge. We actually couldn't open LC, the letter of credit, to actually transfer money to purchase equipment, and then some companies, like my company, actually they tried to bypass the sanction. So some of the equipment could be supplied from China indirectly. So China goes to buy equipment from the European countries, and we actually buy from China. So the cost of the equipment would go up. And also, because the sanction was on the oil and gas industry, we actually couldn't sell our oil to the European countries. And what happened? Instead of going to European countries, Iran tried to sell some oil to the China. Instead of giving money to us, because of the sanction and transfer of money, they couldn't give the money, and so they said, you should buy equipment from us instead of, So that was the situation, and we actually bought some equipment, especially when I was working in iron ore, and they were trying to develop the concentrator plants. They actually had a huge purchase from China with very, very poor quality, even though we have our own manufacturing in Iran, but that was very sad. And in terms of our communication with the other countries around the sanction, the time we actually couldn't, they were not responding to our emails, even for the contracts that were on, and they were not sending their supervisors to my side, because when you buy equipment, you have to have the supervisors around the commissioning time. But that was the situation in terms of the communication with the sanctions. I already talked about the problems, but I haven't talked about the potential. But I think, in my belief, I really think if the sanction is taken away, is removed, there are quite high potential for cooperation between Iran and the other countries. And specifically talking about the industry of minerals in Iran and JK, I really believe that it can be some cooperation in there in terms of the training, in terms of like what JK does for the other countries, for the plant survey, and we don't have any optimization. It is a potential, and about the models, we have the same situation. I really believe that if the sanction is removed, there are some potentials there in terms of the cooperation. So that was my talk today, and thank you for listening, and I'm happy to take any question regarding this presentation. want to export to the other countries, especially China. But I'm not sure about the current situation because the iron ore came down, but still they are continuing to produce, install the iron ore plants. And about, since 2007, about 22 million ton per year iron ore concentrator. They are installed, they are under commissioning or completed. Yeah, that's the situation. Yes.
I've got a technical question about the HPGR survey that you were looking at. You said that if the screen got finer, the throughput would be reduced, but you're only using 20% of the power. Surely you could have made the screen finer, still used wet screening, and kept the throughput the same, but just utilised more of the power. Was that looked into?
You mean like reducing the aperture size?
Yeah, because it was was it 10 millimeters or was it?
Pardon?
6 millimeters.
6
Yeah.
millimeters,
So you
yeah.
can reduce maybe down to 4 or something like that, and then that would be pumped easier.
Yeah.
Or,
6 below 6 millimeters is pumped to the hydrocyclone.
okay.
Yeah, I think now actually when you reduce the screen aperture, the capacity comes down because this is the screen undersize, the capacity is screen undersize. They could actually increase the screening area. That's what they could do.
Also the screen.
The screening
where
area,
the
to
limiting
get to
factor.
the same throughput, yeah.
Yeah, because I was wondering, because I thought maybe it was the HPGR that they had very low.
Yeah,
Power,
very low,
so-
yeah. I think even the problem they were having with the angularity of the particle, it was because the HPGR there was running like a crusher. It
Yeah.
wasn't actually running like the HPGR. And that was, they were not taking care. They said, no, it's working, but HPGR there, to me, it was not, it had no application. Even without HPGR, I'm sure we could actually run a plant. So, but sadly, they had installed about 14 HPGR in Iran for the primary grinding. Yeah. That's it.
Have you had any experience dealing with the sanctions?
Me, myself. Yeah, I was around the time I was in company. Yeah. That's why I know exactly what's happening there. Yeah, that was sad, but the company was trying to bypass the sanction. They actually, what they did, they actually established a company in China with a name that no one can realize it's an Iranian company. They were doing something to bypass the sanction. And the other thing is when the sanction came, because for the new plants, they couldn't actually get the HPGR and ball mill. For HPGR, I'm not sure, but they actually approached Copen instead of the ThyssenKrupp. I don't know why Copen can work with Iran, why Polysius can't. But for ball mill, I know that they actually tried to to assemble ball mill themselves. So they would actually approach the same companies, because for ball mill, let's say, they actually get the hydraulic system from a company, the shell from the other companies, and Polysius actually assemble together and then give it to Iran. But around that time, what my company did, they actually tried to approach this company separately and to assemble ball mill themselves. I'm not sure how much it is successful, but that's the situation.
I understand that they're starting to lift some of the sanctions.
Pardon?
Are they starting to lift some of the sanctions now?
Yeah, it's been
Yeah.
told in 1 month or 1.5 months, but not completely. I think if they say they had agreements, they start to reduce down the activities for nuclear energy, things like that, and then the sanction is lifting gradually, not completely, But still, that's my point. Even the sanction is on, we still have some cooperation with European companies, and I know some companies in Germany. they actually, Iran send the samples to them and they do the testing. They do that, they still cooperate. I really don't know how, but they do.
You just had to prove that it wasn't going to be benefiting for a reduction in uranium, but that would feel difficult.
Exactly, sorry, I couldn't.
You just had to prove that it wasn't going to be relating to the concentration of uranium, but to prove that was very difficult.
It was difficult, but you know, the cost of everything going up. The problem is they can still do that, but the cost is going up. And I'm not sure, but some companies like ThyssenKrupp, they really refuse to do cooperation. I think because they are very well-known companies, and if they cooperate, do work with Iran, they got fines, you know, that's the situation. But they still do some, and I believe for here, my company, actually after I came here, they actually asked me if I can do some work on JKCMed and then work with them. I said I can't do JKCMed myself and give you the results, you know, that's the situation. But they were willing to buy JKCMed from here. But the situation is with the money transfer. But I think this problem also can be tackled. Mohsen, Mohsen, he was in Iran months ago, and I asked him how the things going. He actually approached some not company. It was the government, the organization, governmental organization, and they were willing to buy JKCMed and be trained by the JK Tech people. But the problem is the money transfer. I think there are some ways to do that. I'm not sure, I'm not expert in this system, but
the problem is not just money transfer, because they request to buy JKCMed or Simple last year, but it was refused because of the sanction. So JK cannot sell the product because of the sanction. It's not just the money.
that's my point. Even
The
though the sanction is on, the sanction is everywhere to European
It
countries.
depends
Why
on
they
how they translate that, because there is a sanction from UN and US. Australia is a country that takes these things seriously, so
yeah, that's the
reason.
point.
I think this sanction can be removed anyway, even not this year, next year, and then will be like a competition to enter this market. Like CSIRO had been already there, so they just wait for the green light to go. It's a huge potential,
I know, but
as you see. So
We're
but what I hear.
We're working through two approvals at the moment with
Yeah.
DEFA
yes.
for Iran.
Even for PhD student, even started from gas and mining and uranium and precious metal, but now when you say copper flotation, still there is a question about that why you do copper
Yeah,
flotation.
what I hear from companies in Iran is Australian are too expensive, you know, that's what they say, but but even seriously, they still selling, European are also very expensive. I don't know how they can, approach Iran and then take benefit, I'm not going, everyone goes and take benefit from my country, I really hate it, but but I think there can be some cooperation here, especially I really believe that JK and industry in Iran can be. I'm not sure in which way, but there are, I think I've been there several months ago and I was talking to a guy in the company, and he was, they actually asked me for that JK take, but later they said no, Australian are very expensive, but I'm sure that they pay more money to the European countries, I'm sure. That's my problem.
Electricity. How's electricity generated? Coal,
Coal, yeah.
diesel, gas,
Coal.
mainly coal.
Yeah.
Yes.
No, mainly coal.
gas.
We have some gas, but the electricity is mainly from.
There is one from nuclear.
I didn't actually show the uranium distribution in Iran, but anyway, I don't want to go.
Is there much exploration going on for other copper deposits? Other than the two big ones?
They are, yeah, they are.
Is that government
Yeah, it's
exploration?
government. And then there was a plan to actually give the exploration to some private sectors. They can do exploration, and they were encouraging them to do the exploration. And I think mainly recently was for the chrome. Yeah, I'm not sure about copper, but I'm sure about chrome because we have lots of chrome, the lensy chrome.